All right. Well, welcome everyone once again to another last minute scheduled office hours based on ongoing current events. I'm going to give folks a little bit longer than usual to filter in because I know a lot of folks are directed through Twitter, and it seems that Twitter has broken its own internal linking system. The API doesn't appear to allow any outbound links at the moment. So, might take folks a few minutes to figure that out. But in the meantime, just wanted to do a little bit of housekeeping and remark that just a reminder that I won't usually be doing office hours quite this frequently, but when I do them, they'll more often be focused in the long term when there isn't so much active weather in California, focused on longer term things, climate change and how the West is changing, and in particular California. So, in the short term, though, because there is so much going on and so much potential for high impact weather and a lot of confusing social media communication in some cases surrounding it, I'll continue to have these in the short term to work through these issues with folks. Um, let's see, what else is going on housekeeping wise? I think that's about it in terms of the housekeepings, and I can see folks are rapidly filtering in now, so I'm just going to dive right into it and then start asking some questions and just toward the end of the office hours. Again, I'll try and devote about 45 minutes to this one. Uh, well, it's been another remarkable week of California weather. The last week was remarkable mainly for the additional very heavy snow accumulations and blizzard conditions that occurred in the mountains of Northern California. In and of themselves, they wouldn't be quite as remarkable. It's just that they've occurred on top of already extremely heavy snowfall in the weeks previous. And so now the cumulative effect of all of that snow, including snow that has continued to fall at unusually low elevations, not quite as low as it did a week or so ago, but down to 1,500 feet, which is still really low to see a prolonged period of snow accumulations. Really, there are two major effects that have been very problematic for certain folks. In the high mountains, in the high Sierra, so we're talking up above 5,000, 6,000 feet or so, the total volume of snow is now kind of ridiculous. In some places, it's approaching record snowpack accumulation levels for the time of year. It isn't yet there on a statewide basis because the northern Sierra is only somewhat above average, but in the central and southern Sierra, the snow amounts we've seen are really remarkable. And there are starting to be structural issues. Buildings are starting to collapse literally under the weight of the snow, which of course is notable because these are buildings built in places that are historically very snowy. So for them to collapse under the snow loading from this sequence of events says a lot about the historical significance of this particular sequence of events. Folks, I think I've seen the footage of bumper cars on just about every highway in the Sierra Nevada. Highways 80 and 50 have been closed, I think, more often than they've been open, or if they have been open, it's really just a one lane carved by the rotary snowblowing machines from Caltrans through huge snowbanks. Not a great time to be up there or traveling. The chairlifts at the ski resorts keep closing due to blizzard conditions. Some of the chairlifts at the highest peaks are no longer that high above the snow itself, so that's starting to become an issue. The bigger issues, though, I think are happening in two other places. So at least in these places, there is snow removal equipment. Most folks are aware you can get big snows at high elevations in the Sierra. Bigger problems are emerging at lower elevations in the foothills, so between about 2,000 and 4,000 feet elevation, all throughout Northern California. There are reports of folks who've been without power for now 7 to 10 days. Folks are essentially trapped in their homes without electricity, heating, and some folks have been running out of food and potable water, so there have been some real progressively more extreme evacuation and rescue scenarios unfolding. The Coast Guard and the National Guard have been airdropping hay to cattle up in northwestern California. because otherwise, these are animals that have been without food for many days, and folks can't really get to them because a lot of the places in these lower elevation areas don't have much snow removal equipment. So when you get 1 to 3 or even 4 feet of snow, as had occurred in some of these 2 to 4,000 feet elevation locations, including in the coast ranges in California, this is not snow that's going to melt quickly. It's just sitting there, and folks it's really difficult to get around, especially in some of the more isolated rural areas, because a lot of the snow removal efforts have been focused, as you might expect, on the major transportation routes, not the small rural roads. And so this is becoming a real big problem. Places like Lake County, interior Mendocino, all up to the north coast. And then there's also been a major issue in Southern California, particularly in the San Bernardino Mountains, where there's been some pretty dramatic imagery of folks who have been stuck now for days, again, in their homes, and structures have collapsed, roofs have caved in. There are a number of folks who perhaps have moved to the San Bernardinos in recent years where there has been very little snowfall, and now in this one sequence, many feet of snow fell at once, and folks were unprepared. It seems like some of the emergency response folks were unprepared as well, and I think that's a combination of two things. One is that this really was a truly extreme snow event in Southern California relative to anything we've seen in recent decades, going back about to the 1980s is how far back you have to go to get an event of comparable magnitude. Of course, the 1980s feel like they were a lifetime away climate-wise in California. It was a cooler time, so it is really even more extraordinary to get a comparable event today. But the long and the short of it is there's a lot of folks who are still in pretty bad shape, stuck up there in the mountains, and I think that there's finally some help getting through in Southern California. But there's a real challenge up in the coast ranges and between about 2,000 and 4,000 feet in Northern California, because the snow up there has continued to fall. At least in Southern California, it's mainly been a matter of what fell about a week ago and has been slowly melting, and there's been slow progress. In Northern California, the snow just keeps piling up. So there have been some direct issues from the extreme snowfalls in and of themselves that folks have been struggling with, and I think reports are still continuing to come out, and I think there's going to be some untold stories out of these areas because the power and even cell networks now have been down for many days in these areas because we still don't have power outage resilient telecommunications in a lot of places, because now this is something a lot of folks learned during wildfires, is that a lot of these cell phone towers have battery backups or even diesel generators to provide a few days of backup. But once you start getting power outages that last more than a week, which now has happened almost every year in California in recent years, at least locally and in rural areas, and you can't get people in there to resupply the diesel, then you run out of cell phone coverage. And now landlines are less common, and often it turns out telecommunications providers run landlines through digital centers that require electricity. So the redundancy that used to exist with landlines being usable even during power outages is not always true anymore. So in some cases, folks are more isolated during extended power outages today than they would have been 40 or 50 years ago, when landlines often still would have been available as an option. So just some perspective into the challenges being faced by some folks in rural California right now. And there really have been people who've been out of power now for 2 full weeks and with no immediate estimate of restoration, mainly PG&E territory. So that's where we are today. Yet more snow still continues to fall in Northern California and the mountains, although the extreme snowfall is tapering off. I don't think there'll be any more extreme snowfall this week, but there will be additional locally heavy snowfall. The snow levels will continue to rise this week. They won't be as extremely low, so this will help with gradual snowfall recovery throughout the state between about now and Thursday. So there will be better weather this week in general to help folks dig out and reconnect the power grid in these places. And I hope that happens, because the weather then starts probably to deteriorate again, but in a different way, starting late Thursday or Friday. And that is going to be the focus of the rest of this conversation. So there has been a pretty major evolution in the forecast for this coming weekend, especially in Northern California. To summarize, it now appears increasingly likely that a potentially significant, and very likely warm atmospheric river event will probably affect some portion of northern or central California sometime between about late Thursday and Saturday. There's a lot of uncertainty at this point regarding how intense it will be, how prolonged it will be, and the impacts it will likely have, as well as whether it will be followed by additional warm storms or not. All of that is up in the air. However, confidence has grown that a warm rain event of some magnitude will occur later this week. So this is not short-term imminent. Everyone does have a few days at least to prepare, if not more like 4 or 5 days. But this is no longer on the distant horizon. It's something that kind of jumped into focus more suddenly over the weekend. And the focal point, temporally speaking, is definitely now late Thursday into potentially Saturday. Why did things change so much? Well, there have been a lot of rumblings about 1 to 2 weeks in the past. So this is going back a bit farther about the potential for a transition to a warm rain pattern. And I just want to be clear that the initial rumors turned out not to be correct. We would already be experiencing that warm rain pattern if the original operational control model runs were right about the timing and the magnitude. We'd currently be experiencing a severe warm atmospheric river today, right now. Clearly that is not happening, and so that initial outlook was I guess you could call it premature, now that something does look like it's more likely to happen later this week. But the interesting thing is that when you use, last conversation I talked a lot about ensemble modeling and the need to use the full range of statistical outcomes from these dynamical models and not focus on individual ensemble members, because often, if you run the same weather model 30, 40 times using similar but slightly different initial conditions, you can get 30 to 40 pretty different outcomes, and often they'll cluster in one direction or another, and that's sort of where your best bet prediction is. But they'll frequently be large outliers, individual model runs that are big outliers. In fact, at any given moment, you can usually find 1 or 2 individual model ensemble members that predict some sort of historic or truly extreme event. And the reason why we don't focus on those outlying members is because they rarely actually come to fruition. It doesn't mean they can't, and in meteorology and in climate science, we increasingly view those outlying ensemble members as indications of what could physically happen in the system. So presumably, if at least one member shows an event at some point, it's not physically impossible. It's within the range of things that could theoretically happen, and I think that's a reasonable way to think about it. But if it only happens in one member and sort of flashes in and out of existence from one model run to the next, it's not very likely to happen. And if we worried about every single extreme or historic event that occurred in individual ensemble member model land, that's pretty much all we'd ever be doing, because at any given moment there's almost always 1 or 2 members that show something that would be, if it came true, alarming, but probably almost certainly in some cases won't happen. So what happened between last week and this week? Well, on Friday and Saturday, the likelihood of a major warm atmospheric river actually had decreased. So last week the odds were hovering around about 1 in 4 to 1 in 5, so about 20 to 25%, meaning that there was about a 75 to 80% chance from the ensembles last week that really nothing was going to happen this week with a warm atmospheric river. Definitely not zero odds, 1 in 4, 1 in 5. They're low-ish, but they're not extremely low odds, and I think that's what we were really focused on communicating last week. On Friday, those odds dropped further to about 1 in 10. Only about 1 in 10 ensemble members were showing a warm atmospheric river for this week, and so the odds in relative terms actually decreased late last week from their already reasonably low levels. And so some of us were optimistic that that would mean that this event was sort of, this hypothetical event was on its way out in the probability distribution, but it never went to zero. There were, it sort of reached a minimum around a 1 in 10 chance based on the broader model ensemble envelope. And then suddenly on Saturday, there was a dramatic shift. So then we went from our low point of about a 1 in 10 likelihood this week to a greater than 5 in 10 estimate in just one model run. And then subsequently, the odds have risen even further, and they're more like 7 or 8 out of 10, if not higher, for a warm atmospheric river event of some magnitude later this week. That's a pretty dramatic shift, and that's a bit unusual to occur across the entire ensemble so close to the event in question. So it's not unusual at all for individual model members, so the control run, the operational run, as I keep referring to sort of oscillate wildly from run to run. But that's because it's only one iteration, one set of initial conditions. But for the whole ensemble, which of course is designed explicitly to capture the uncertainty in initial conditions, and you sort of perturb those initial conditions and get a bunch of different iterations, usually that entire ensemble doesn't shift really rapidly in one direction or the other. If it's going to shift, it does so somewhat gradually. That did not occur this time. This was literally an overnight shift in this case towards a much wetter, warmer outcome and a much higher likelihood of atmospheric river storms. So that's where we are now. Why did that happen physically? Well, clearly, in retrospect, the ensembles were what you might call statistically under-dispersed, meaning that they were insufficiently circumspect about the range of outcomes that was possible. Why is that? Well, physically, in this case, it kind of makes sense because what actually has to happen, the pattern we're seeing, this is different than the big wet pattern we saw in late December to early January. Then there was just this huge, continuous, extended, essentially Pacific jet stream that extended all the way from the West Pacific to the East Pacific, almost west to east across the entire basin, a pipeline of storms and moisture from the west. That is an easier pattern for the models to get a handle on because it's a relatively linear pattern, at least in terms of the jet stream position. It's sort of just a straight line, more or less west to east. In this case, we actually have a huge ridge to the west of California, over the Gulf, in the Gulf of Alaska. And what's happening with this what now appears likely to be a warm and wetter pattern is that there is what's known as ridge undercutting. So the jet stream is sort of circumventing that big ridge and going underneath it to the south on the equatorward side of the ridge. So rather than having a long linear jet stream all the way across the Pacific, there's actually a jet stream that's sort of going underneath this ridge and even reforming a little bit to the southeast of it, just southwest of California later this week. And this is one of the reasons why we're more likely to see warmer, wetter storms, is there could be a Pineapple Express type atmospheric river connection, depending on how things work out. And so this is a pattern where there's a very wavy jet stream and a very wavy pressure pattern over the North Pacific Ocean. Again, it's a very different pattern than what we saw in December and January, which was so wet in California, which brought all these storms. Well, this is the other kind of big pattern that can bring really wet conditions, but it tends to bring much warmer conditions. Rather than cold and wet, this is a relatively warm and wet pattern. And the reason why the models were likely under-dispersed in this context is that it's kind of a razor's edge pattern. There's a very fine line between this ridge just being too big and too blocky to allow any storms through to being just far enough to the north and just weak enough to allow this undercutting by the jet stream to occur. And then also for the what's known as phasing of subtropical moisture and mid-latitude cold storms. So that's essentially whether or not this extensive plume of subtropical moisture from near Hawaii can sync up, if you will, with the colder storms diving south from the Gulf of Alaska. If they miss each other, we'll just get a big warm plume of moisture without a lot of dynamics to squeeze out the moisture. So it's nice and warm. You get some rainfall, but nothing really very dramatic. It's mostly light to moderate rain in the mountains, orographically forest. Or if we just get the cold storms, we'd get yet more snow in the mountains, but probably no super heavy precipitation because the subtropical moisture would miss. The biggest storms often occur when they, of course, connect, and you get that subtropical moisture plume that interacts directly with these cold storms from the Gulf of Alaska. These are many of California's big storms and flood events occur when that sort of thing happens. And there's still uncertainty the extent to which this is actually going to occur, but it does appear there will be some degree of phasing of these storms. Will they result in a more of a weak to moderate type atmospheric river storm, even if it's really warm? Or will result in a stronger atmospheric river, Pineapple Express type storm, which would cause greater problems. We don't know yet, but it does look like there will be quite likely a warm atmospheric river of some magnitude later this week. It could still be weak to moderate, but it could also be strong, and the most likely outcome is a moderate strength warm atmospheric river later this week of moderate duration. So, what will that mean if it happens? Well, if the most likely outcome occurs, a moderate strength atmospheric river that is of moderate duration, this is not going to be a widespread catastrophic flood event, as some folks have become really concerned about online. It would be an event that would be disruptive in some places and will cause some problems and some flooding, but it isn't going to cause a catastrophe. Just to be really clear, that would take a much stronger and longer duration storm than is currently being depicted by almost all of the model ensemble members at this moment. That said, it is going to probably cause some issues, and there is going to be rising flood risk later this week. Where am I most concerned right now about flood risk? Well, it's actually not at the highest elevations where the snowpack is the deepest, because the snowpack is in fact so cold and so deep right now, it actually has a lot of potential to absorb even a fair bit of rain that might fall on it. So we currently don't know exactly how high snow levels could go. They could be as low as 6,000 feet, which would be pretty unremarkable, or they could be much higher, around 8,000 or 9,000 feet, and that would result in a lot of rain on snow, even at, say, Lake Tahoe level, which would cause more problems. But if it's closer to 6,000 feet, then really the only rain on snow is going to occur at lower elevations, between about 2,000 and 4,000 feet or so. And that is where we have the highest confidence in flood-related impacts. So we're talking in the foothills and in the coast ranges, places where there is an unusually deep snowpack right now, because as I mentioned, we've been getting a lot of snow accumulation at 1,500 or 2,000 feet, which is not typical for Northern California. So in that 2,000 to 4,000 foot elevation band, there is a high potential for the upcoming warm atmospheric river on Friday or so to melt a significant portion of that low elevation snowpack. So there we will have the combined influence of whatever rain occurs, and it could be heavy rain in its own right, plus the additional runoff from the snowmelt up to about 4,000 feet in elevation. That's the small rivers and streams and urban areas in those elevations are going to see some significant potential for runoff issues and some flooding, particularly in urban areas, because in some cases the storm drains are clogged by snow, and so individual streets and locations where that's an issue are going to potentially see a fair bit of urban flooding as well as small stream flooding from this event. Higher up, up above 5,000 or 6,000 feet, I still think that the snowpack is likely going to absorb most or all of this water without contributing greatly to a major flood event at those elevations, or a major snowmelt event that contributes to huge runoff at lower elevations downstream. But the big problem, I think, may actually end up being at higher elevations. We're already seeing problems with structural collapses and roof cave-ins from the heavy snow at these elevations. If you add a bunch of water to that snowpack, it doesn't necessarily get deeper, but it sure gets heavier as that snow absorbs more water. And so you may actually start to see additional structural issues from heavier snow loading. So again, even if it's rain falling on top of snow and that snow is not melting significantly, that accumulated snowpack on your roof might actually get significantly heavier. So I know it's a daunting task, but if you're at 5,000, 6,000, 7,000 feet elevation anywhere in California right now, or even if you're at lower elevations, because even in the foothills there is some significant snowpack that might take a while to melt. There might be some water absorption before the snow melts. If you can, go out and try and remove some snow from structures that might be vulnerable. Do it sometime between now and Thursday. Probably Wednesday or Thursday will be your most favorable weather days to do it this week before potentially significant warm atmospheric river arrives. Okay, so peak flood risk in the foothills from this. This does not necessarily look like it's going to be an extreme rain event at lower elevations. Right now, it does not look like the dynamics are going to perfectly sync up with the subtropical moisture plume to produce very strong winds or very heavy rain at lower elevations. In fact, this could potentially be an event that is sort of a non-event, at least at low elevations, but a much more significant event up in the mountains. So it could be very strongly orographically driven, where there could be quite a lot of rainfall on the western slopes, the windward slopes of the mountains, and only a relatively moderate amount of rainfall locally heavy at lower elevations. That's still subject to some uncertainty. It could scale up a bit. There could be heavier rain at lower elevations, or it could end up being pretty light at lower elevations, where there's high confidence of some heavy rainfall is up in the mountains, and that's of course the subject of concern because there is so much snow up there right now. So just how high the snow levels get, just how high the rainfall is still uncertain, but a moderate strength warm atmospheric river is currently the likeliest outcome, with some potential for moderate flood risk, particularly in the foothills, and some additional kind of unusual risk of structural issues from increased snow loading as snow absorbs a lot of water, especially at the initial onset of precipitation, that could cause problems in places with ongoing, unusually heavy snowfalls at different elevations. So that's currently my peak concern right now. And there could be some flooding elsewhere, but right now this does not appear to be an extreme flood scenario anywhere in California. Now, talking a little bit about the longer ranges where things get a little bit more interesting, if you will. And really the concern right now would be, I don't think the atmospheric river storm, even if it trends a little bit stronger and ends up being a strong but moderate duration atmospheric river, I don't think it's going to cause severe flooding, generally speaking, in California, although it will almost certainly cause some flooding, of at least minor flooding, maybe some moderate flooding. But I don't think widespread severe flooding is likely. In fact, I think that right now, the Friday-Saturday event will produce less flooding overall than the events we saw back in January. However, that is subject to change if the median intensity estimates go up. It's also subject to change if the snow levels end up at the very high end of the expected range. So if they end up at 6,000 feet, of course, that would be most favorable. If they end up at 10,000 feet, we're talking about a fairly different storm. But the greater concern is what happens in the week following. And as I've emphasized throughout this, the highest risk of snowmelt-related flooding is going to be still later this year, so late March, April, and probably into at least part of May. And the concern, there were two concerns that I've been voicing since about late December, since we started accumulating this huge snowpack, in which I've been talking about with folks at the state of California, the Department of Water Resources, various flood control folks. There's really two mechanisms of concern. One is the potential for prolonged series of warm atmospheric river storms. So not just a one-off event like we're going to see Friday, but the prolongation of that storm train and the successive waves of warm rain atop a huge snowpack. That would be a significant problem and pose greater flood risk than we're likely to see on Friday. The other possibility is a particularly prolonged or intense early season heat wave. We're still a little bit too early for that. It's still early March, but that's something that becomes more of a concern in April and into early May. Now, the challenge is that there are some model ensemble members right now from both the European and the American models that suggest that there could be additional warm atmospheric rivers following the first one. So the first one being the one on Friday, the one where I said that anything more than moderate flooding is somewhat unlikely at this point. That could potentially change if we do get an additional 2 or so atmospheric rivers, warm atmospheric rivers, that follow in relatively close succession after the first. And right now, that does appear to be a possibility, although again, it's still not the most likely outcome. But there is some potential for additional warm atmospheric rivers to follow the first. And that's where my main concern rests right now. It's not so much with this first system, but it's the question of whether this first system is priming us for a bigger problem down the line. So the big quote-unquote bigger problems I'm talking about wouldn't probably occur for another 8, 9, 10 days. So we still have a fairly long way to go, or even potentially out closer to 2 weeks from now. But there is some potential for greater flooding if we do get additional successive warm atmospheric rivers following the first, and that does appear to be something where there's about a 1 in 3 possibility of that. So the odds are not that low right now. So this is something that is a greater concern as we head really into mid or late March. And that sort of falls into that window that I keep mentioning of later in March and April being the peak window for concern regarding the potential for snowmelt-related flooding in California. That is where we'd expect it to peak, and that is very well where it may peak here. And in this case, the concern would be not so much the early season heat wave, but that successive warm rain, warm storm scenario. Again, still not the likeliest outcome, but it's also not a very unlikely outcome either. It is a plausible outcome in the next couple of weeks. And so we'll keep a close eye on that. But again, the first storm is going to cause some problems. I don't think it's going to cause widespread severe problems, but it could cause some unusual problems in unusual places that have an unusually heavy snowpack right now. So this will be a bit different. I don't think we're necessarily going to see huge flooding on the main stem rivers. I don't think we're necessarily going to see huge flooding in the major urban centers of Northern California, but in the foothills, in some smaller communities and in some more rural communities, that could be a different story, and there could be some structural issues with really heavy snow loading as rain gets absorbed by snow. So that's currently my thinking for this upcoming storm. If this changes dramatically, I will probably have another office hour later this week. In fact, I might do that anyway. I'm also planning on having a new blog post on Weather West in a day or so, once it becomes a little bit clearer what the Friday storm looks like in terms of magnitude, and whether it looks like it's more or less likely that we're going to get those successive waves of warm rainfall in the next couple of weeks that would really escalate flood risk well beyond what we're likely to see on Friday. So I think that's my narrative summary. There's a lot of folks watching today. In fact, this may actually be the best attended office hours so far. So clearly there's a lot of interest in what's going on right now, and for understandable reasons. I'm going to go through some questions. Let's see here. There's a question about what the role is of El Nino and La Nina. This is from Corrine, in all of what's going on right now. And the answer is it's often difficult to say for specific storm sequences, except in retrospect when you do some analyses. But here's some general thoughts. First of all, we don't have El Nino conditions in place right now, so we can't really blame this on El Nino. We have had significant La Nina conditions in place, but they are rapidly going away in the tropical Pacific. So we do have sort of the vestiges of La Nina. And to be fair, the current weather pattern is actually more of a La Nina pattern than the one we had back in December or January. So that very extended linear west to east jet stream from East Asia that I was talking about, that is more of an El Nino pattern than a La Nina pattern, but it occurred during a La Nina year. So it definitely wasn't because of El Nino, because El Nino was not occurring, and it wasn't because of La Nina, because La Nina tends to do the opposite. So our December-January pattern was just pretty weird, to be quite frank. The current pattern, with this big blocking ridge over the Gulf of Alaska, but an undercutting pattern with some subtropical moisture mixing with colder mid-latitude systems near California, that is something that's a little bit more reminiscent of what we would expect if we were to get a major rain scenario during La Nina. This is often how it would happen because of that persistent high pressure in the Gulf of Alaska, which La Nina favors. But if it's far enough west, and if you get enough phasing of that subtropical moisture, as I was mentioning, you can get a pattern like this. So this is actually more of a La Nina-like pattern than the wet stuff we had back in December. And is the main factor in this case is a different question. One thing I will mention, because this is interesting, is that there's actually about to be a very strong westerly wind burst in the eastern tropical Pacific Ocean. This is going to really work to kill off La Nina once and for all and set the stage for what I still think could potentially be a significant El Nino event beginning later this summer into the fall. We'll talk more about that later, but the atmosphere is starting to do things that would favor getting rid of La Nina once and for all and really building that El Nino event. As has been predicted by dynamical models and human forecasters for some time, there's now evidence that that is in fact exactly what is starting to unfold. So stay tuned for that. I don't think it's really affecting California's weather yet. It's since that condition does not yet exist, but we are seeing the preconditions for a pretty dramatic shift from a very prolonged and quite strong La Nina event over the past couple of years to an El Nino event that could potentially be a major El Nino event in the coming months. So stay tuned for that. Let's see here. All right, talked about high pressure and the location there. Yep. Hi, Alex, former UC Davis atmospheric science alum, who remarks that up in South Lake Tahoe, folks are very much not looking forward to any additional significant weather, which I totally understand. I think a lot of folks who live up at those elevations are burned out. Folks at the Weather Service and emergency managers are burned out because it's really just been one thing after the other. It's also been a notably different sequence of things to be burned out from than in recent years. So drought and extreme wildfires, even in South Lake Tahoe specifically, has been more the norm in the past few years, and now this year we just have this this extreme snowfall and the rain on snow kind of potential coming up, which is a very different kind of problem to have. There's some experiential whiplash. We talk about the geophysical hydroclimate whiplash, but people also experience the challenge of context switching from one type of extreme weather event to the next. And it is challenging. It is genuinely, I think, difficult for a lot of reasons. And I think it's probably why so many folks have been caught off guard, because it's so different than the kinds of extremes we've been more often experiencing in recent years. Folks who've moved to these places, I know that for a fact there's a lot of people who moved to the foothills, to the Sierra, to the San Bernardino Mountains during the pandemic era, during the remote work era, folks who weren't perhaps as familiar with the background climatology and geography of these regions. So I think that is perhaps part of what's going on, is there's a lot of newcomers who have moved to these places during an extreme drought and wildfire climate change amplified era. Well, now we're experiencing a particularly cold and wet period, and that is resulting in a whole host of new issues for folks living in these areas. And so I think one lesson is that just because the climate is getting warmer does not mean that we will not continue to see extreme snowfalls at the high elevations in California's mountains. In fact, we talked last time about why perhaps the most extreme snowfalls might even become somewhat more extreme at high elevations in the west, even as the average snowpack declines. And I think it really points to the fact that what we need to be thinking about, both at a societal level and a statewide level from a governance perspective, but also from an individual disaster resilience perspective, is increasing whiplash. This notion that we go from one extreme to the other, very dry to very wet, and from extreme wildfires to water overabundance problems. Obviously, we're working that into, as we work with state and federal partners into planning at that level. But I also think that individual folks probably should be thinking about it as they prepare in their own communities and in their own homes for these sorts of things that are likely to be coming down the pike. Let's see here. Hi, Rachel. Just wanted to quickly read your question here. Rachel asks, can you talk about the National Weather Service storm forecast for this week, which looks to be a significant flood threat for the Central Valley? What should we watch out for? I think at this point it's still uncertain what kind of flood threat is posed to the Central Valley. But if there is going to be a flood threat in the Central Valley, it is going to be highest in the southern Central Valley, so essentially the San Joaquin portion of the basin more so than the Sacramento portion. And there's a number of reasons for that, one of which is that the amount of snow in the Central and Southern Sierra is actually a lot higher than in the Northern Sierra right now. The Northern Sierra is only slightly above average, but the Central and Southern Sierra are approaching record snowpack levels. And also, the San Joaquin River system, the watershed in the southern half of the Central Valley, is really more vulnerable to snowmelt flooding. Partly because there is a larger snowpack to melt, but also because the San Joaquin River system is less well managed. There are fewer flood control reservoirs on the rivers that feed into the San Joaquin River, and the San Joaquin River itself has fewer flood control structures on it in the Central Valley. And so there has been a lot of speculation that in a warming climate, some of the most rapid increases in flood risk are likely to be on the San Joaquin system, more so than the Sacramento, although both places will see an increase in flood risk. And that is a combination of factors due to the geophysical reality that there's likely to be more warming of atmospheric river storms and therefore more new contributions of snowmelt flooding or rain on snow events to runoff increases in the San Joaquin system, but also because the existing human interventions on the San Joaquin are perhaps less impressive than on the Sacramento system from a flood control perspective. And so that is something we could see play out either later this week or perhaps more likely the following week if there are additional atmospheric rivers to occur. It's a combination of geophysically which places are most at risk and also from a human intervention perspective where are the vulnerabilities greatest, and that tends to be the southern half of the Central Valley, particularly the San Joaquin watershed. The interesting part here is that we still don't know exactly how strong this atmospheric river is going to be. We still don't know exactly how high the snow levels are going to be, and that's really going to affect how significant the flood threat is in the valley. Because, of course, the Central Valley is not at risk from the system because of the rain that's going to fall in the Central Valley primarily. If there is any flood risk in the Central Valley, it's going to be because of water that falls in the Sierra and potential snowmelt from about 2,000 to 5,000 feet in the Sierra primarily. It's not so much because of really heavy precipitation in the valley this time around. And so it's really going to depend on just how high these snow levels get and how many additional atmospheric river storms are coming behind it. I'm not so convinced that there's a high likelihood of major flooding from the Friday storm alone, but again, the bigger problem comes if storm number 2 or 3 does line up behind it and there are additional warm storms, which again appears to be about 30 to 40% chance that happens, so that is not a particularly low chance at this point. It's not extremely high likelihood, but it is a distinct possibility. That is where the greater flood risk would probably arise, particularly, again, focused in the southern half of the Central Valley, the San Joaquin watershed, but that would probably be most pronounced if we do get atmospheric rivers 2 and 3, and that is still uncertain at this point. So it's not just a question of what happens Friday into Saturday. There will probably be some flooding then, but the risk of much more widespread and greater flooding would probably occur the following week if we do get those follow-up storms following on the heels of the first. Let's see here. Yeah, as Meredith points out, Mendocino and Humboldt Counties have been really struggling. There have been disaster declarations in certain California counties, but not others, in a way that doesn't quite make sense based on where the greatest impacts have been. I'm not sure why that is, but there are definitely a lot of folks struggling up in northwestern California, as well as in the Sierra and in the mountains of southern California. In fact, in some cases, I think folks have been dealing with these issues for longer than in either of those other two places because the snows began at lower elevations up there like 2 weeks ago. So, as I mentioned, there are some folks who've been out of power for 10 days, who've been isolated for 10 days, or locally almost 2 weeks. That's a really long time for that to be the case. And so I appreciate folks calling that out. Let's see here. Yes, someone from North Mendocino is confirming 12 days without electricity. It finally popped on last night. That was sounds like the last time that happened was 1997 up there. So yeah, I think you're not alone, unfortunately. Although I'm glad to hear that things are starting to improve. I do think there'll be some improvement later this week because there is going to be a relative break in the weather Tuesday, Wednesday, Thursday this week. So hopefully that will give utility repair crews and snow removal crews a pretty good window of opportunity to get in there and do some good work before whatever comes down the pike with this warm event on Friday and beyond. Though there's a question, this is related to some questions I've gotten in recent sessions about whether climate change is implicated in the west-wide unusual wintry snowy weather. Is there a pendulum swinging hard for both summer heat and winter cold? I just want to reiterate this again. There is no evidence that climate change is systematically increasing the magnitude of winter cold events. In fact, there is very strong evidence that's doing precisely the opposite, that overall winter cold events almost everywhere on Earth are getting much less cold in a warming climate. For whatever reason, this is sort of a persistent myth that climate change means it gets both hotter hots and colder colds. It does not mean that the colds get colder. It definitely means that the hots get hotter. And there is some interesting science on whether it might mean that the colds don't decrease as much as you would expect from a given amount of warming because of changes to the jet stream, Arctic amplification, and some interesting things going on there. And I think there's some interesting work going on. There is some evidence that climate change could disrupt the jet stream and Arctic polar patterns, mid-latitude interactions in ways that might favor locally over certain continental regions slightly more frequent winter outbreaks of cold. But interestingly, they're not getting colder, and so even as these winter outbreaks might not decrease as quickly as we might expect in a warming climate. In other words, the winter cold might not be decreasing as quickly as the summer hots are expanding. They're definitely not getting colder. And that, I think, is a fairly widespread misconception. The interesting thing is that when it comes to a hydroclimate perspective, so extreme wet and extreme dry, there are a lot of places where it's getting but we're seeing more extreme wets on the one hand, but more extreme dries on the other, California being one of these places. But California in general is not seeing hotter hots and colder colds. So sort of it's the 3 out of 4 thing. We're seeing more extreme dry events, more extreme wet events, more extreme heat events, but we're not seeing more extreme cold events in California. Now the question about this year specifically though, the question about snow is potentially a bit different because as I mentioned in previous conversations, there's sort of these competing effects with snow in a warming climate. On the one hand, the most obvious one is it gets warmer. In many places you're either closer to the freezing point or above it. So you can imagine if you're 1 or 2 degrees below the freezing point on average in winter and the climate warms 2 or 3 degrees, as it has over land in some places over the past century, then you're no longer on the right side of the freezing line and you tend to get more rain rather than snow. We've seen that a lot in recent years, not this year in California certainly, but in most recent years where places like South Lake Tahoe that used to consistently see snow during almost all winter storms are seeing a lot of rain even in midwinter. Again, this year that's not happening this year, but it has happened a lot in recent years. That's because South Lake Tahoe historically was really close to the freezing line during most winter precipitation events, and a couple degrees of warming starts to push places like that to the wrong side of the freezing line frequently, more often than not. There are, of course, major exceptions to that, and this year is one of them, but the long-term trend is still in that direction. And so places that are kind of marginal for snow are getting even more marginal, and we're seeing less snow at lower elevations. It's harder and harder to get snow at extremely low elevations in general in most parts of the world. However, there is a competing effect where as the atmospheric temperatures warm, the capacity for the atmosphere to hold water vapor does increase exponentially. So at locations and at times where it is cold enough for snow and conditions are otherwise favorable, you can actually potentially get more extreme snowfalls in a warming climate conditioned on temperatures that are cold enough. Even if those temperatures that are cold enough are occurring less frequently, when they do occur, there is the potential for heavier snow to fall out of those atmospheres. And there may be a piece of that in what we're seeing in California right now. We're seeing a lot more snowfall records being broken than cold temperature records being broken in California right now, which I think is interesting. And I think this might be relevant in this context. A good example of this is the Arctic, which is warming faster than anywhere else on Earth. And yet one of the most distinct signatures of climate change is a lot more snow in the Arctic, not because it's getting colder, but precisely because it's getting warmer and there's more water vapor in the atmosphere. But of course, in the Arctic, it's still cold, more than cold enough for snow most of the year. It's still below freezing. It's just less below freezing than it used to be, and there's more moisture to go along with it. And so you tend to get more snow, for example, along the shores of the Arctic Ocean. The same thing can happen at very high elevations in the mountains that were historically well below freezing, but are now somewhat less below freezing, but with more moisture. At lower elevations, the temperature, the warming effect tends to win out and decreasing snowfall, but under exceptional conditions, you could potentially see a mechanism for global warming to result in more extreme snowfalls, even as average snowfall decreases and the overall likelihood of snow also decreases. So that's sort of my long-winded answer to that question here. A question from Ryan about current California flood models and whether they're adequately able to take into account antecedent conditions from specifically regarding our extremely large and severe wildfire footprints. I think the answer is no, honestly. And this is a concern. This is a concern that's known and understood, I think, by folks who work in flood control and with water agencies in California. And it's a difficult problem. Because the research on how the hydrologic response to recent wildfires is still, it's more advanced than the operational models we use. So this is a concern. We do know it's not just a matter of that hydrophobic soil. So we often think about, okay, there was a fire in such and such place, and there's some steep slopes, and it was high intensity, and it, folks use expressions like it cooked the soil or produced this hydrophobicity in the surface layer of the soil. And that can happen in certain soil types under sufficiently extreme fire conditions. But there's actually a simpler explanation for why the hydrology changes in mountain areas following wildfires than that, and why it lasts longer, because that hydrophobic soil layer usually dissipates after a year or so. So it's mainly an issue the first year after the major fire. There's a much longer lived effect, though, if you have a large-scale fire that essentially takes out a forest. as we've seen in a lot of places at higher elevations in California, these high intensity fires that have been stand removing. In other words, they've essentially killed off 80 or 90% of the mature trees in a given watershed. And this has happened in places like the Dixie Fire up in Northern California, the Caldor Fire, and places like that in Central California, and any number of other fires in the Southern Sierra, the Sequoia, and up in the Sequoia National Forest, the Sequoia Complex, things like that, in recent years that have been very large fires, but also very high intensity timber fires. In those regimes, you can think about, the mountain hydrology is strongly shaped by the headwater forest. And if you suddenly, in a discontinuous move, remove a lot of the trees in the headwater forest, there's less water being removed from the soil by the trees to do what they need to do to survive, to transpire, to evapotranspire the water through the process of photosynthesis, bring up that water up through the roots into the tree and then back into the atmosphere. But also, as those root systems from the trees that used to be there go away, there's less stuff in the soil column holding on to that water. And so there's an effect that lasts probably at least 5 or 10 years in some of these kinds of places, where runoff for a given amount of precipitation increases quite a bit in the local regions where these high intensity fires have occurred. And as we see high intensity fire patches that exceed 100,000 acres, that's an entire canyon watershed in some cases. And so this is an important factor, I think, that we don't fully have a handle on in our flood operational models yet. It's something that folks are working on integrating, but it's a difficult problem. And so I think places where this is most likely to be an issue would be downstream of the Dixie Fire footprint, which is up in Butte and counties and some adjacent counties that the fire spilled into. And then there's also the Caldor Fire, because it kind of aligns with the Cosumnes River watershed. There's still some question as to whether that's partly why there was much more severe flooding on the Cosumnes with those levee breaks earlier this year relative to adjacent watersheds. And then there's also some issues in the Southern Sierra with fires, not so much that occurred last year, but occurred more in 2020 and 2021, with the really big fires in the Southern Sierra. So this is a concern. It's not easy to quantify it. Folks are working on it, but there is the potential, at least in some of these watersheds, for flood pulses to be a bit larger locally. It doesn't necessarily affect how much water is making it into the big main stem rivers in the same way, because a lot of that water would have made it there anyway, but in a more gradual fashion. So this is a big issue potentially for the rivers that are tributaries to both the Sacramento and the San Joaquin systems, less so the Sacramento and the San Joaquin rivers themselves, but that remains to be seen. So we haven't had a big warm atmospheric river atop a major snowpack in these regions really since we've had these big wildfires. So we might be doing some of these science experiments in real time over the coming couple of weeks. That does make some folks a bit nervous, but I don't think it's going to profoundly change the outcome, but it definitely isn't going to mitigate the risks. If anything, it would somewhat increase the risks relative to what they would be otherwise. So it's going to be an interesting couple of weeks. All right. How bad does the upcoming flooding risk look like for places like Truckee? I think the risk there is more like urban flooding and like flooding on your individual property rather than river flooding in this case, because you're at high enough elevation there that the snowpack isn't really going to deeply melt. It's just too deep and too cold right now. But water that there may be some melting of the snowpack, like literally on your roof or in your yard or in your parking lot. And the storm drains, of course, are full of snow and ice and aren't operating. So you could get water ponding on top of snow and ice, and that's the kind of flooding that you're most likely to get in places like South Lake Tahoe or Truckee with this event. Not so much the river and stream flooding, but more the urban type flooding like that. Which can still be a problem, and it can be difficult to deal with because you can't, you can clear storm drains if they get clogged with leaves. You can't really clear them if they're just full of blocks of ice. So that's going to be tricky. There may be some things you can do to mitigate snow berms and such. So be aware. At lower elevations, there could be some river and stream flooding, though. Places, again, in that 2,000 to 4,000 foot elevation band where it's more likely that most or all of the snowpack could melt, even given a moderate warm rain event, because it is much less deep. So it is possible to melt a foot or two of snow with a warm atmospheric river, it's a whole lot harder to melt 20 to 30 feet of snow, which is what's on the ground in most of the high Sierra, locally even more than that. So that kind of snowpack is mainly going to absorb rain, but a 1 to 2 or 3 foot snowpack is actually much more vulnerable to melting and causing considerable local runoff. So the impacts at high elevations, again, are mainly going to be urban flooding and snow loading structural issues from the water causing the snow to get even heavier than it currently is. Let's see here. All right, a lot of questions toward the end. This is just jump down here, so let me see. Oh wow, there's a lot of things that came in later. All right, here we go. Yeah. Somebody jokes that they want to know exactly whether it's going to rain or snow and when it's going to start, and they're just kidding, of course. Yeah, I mean, I think ultimately there are professionals who are paid to be full-time meteorologists, and the best of them out there generally are in any regional context are with the local National Weather Service offices. So they're very available. They work very hard, and they're very good at their jobs. In Northern California, the relevant offices for this event are probably going to be mainly the National Weather Service office in Sacramento, which covers the northern half of the Central Valley, so the Sacramento Valley, portions of the eastern, or I guess the eastern foothills of the Coast Ranges, or the western foothills of the Central Valley, as well as much of the Central and Northern Sierra. The National Weather Service office located in Hanford, California, which covers the San Joaquin Valley plus the Southern Sierra, and the National Weather Service, which is located in Monterey, but is nominally known as the San Francisco Bay Area office, which is responsible from about Sonoma County down to Monterey County. Those are probably the 3 Weather Service offices that would be most relevant during this event, based on where the warm atmospheric river or rivers are most likely to make landfall. But specific forecasts from weather.gov is a great source. Honestly, folks ask, what weather app do you use? And the answer is, I don't. I just go directly to the Weather Service when I don't want to make a personal forecast for myself. That is my shortcut, weather.gov, wherever I'm going. Sounds like an advertisement, but we've already all paid for it. Taxpayer dollars hard at work. So I strongly encourage folks to use weather.gov and the National Weather Service for their specific weather forecast needs. Because although I am a climate scientist and meteorologist, I do wear a lot of hats these days, so I can't offer specific predictions for most locations. There are other folks who can do it better and have more tools at their short-term disposal to make those specific local forecasts. Question from Meredith. Presumably there could be concerns about roof collapses with unusually high snowpack at lower elevations as well. This is true, especially during the initial hours of the event, before the snow completely melts. So it is possible that after a day or two of warm rain, the snow is largely going to be gone at some places at 2,000 and 3,000 feet. But in the initial hours, there will still be snow on the ground and on people's roofs. And the challenge, of course, is that building codes are different. If you're in South Lake Tahoe, there's a pretty big focus on roofs that are able to accommodate heavy snow loads. That's not necessarily the case at 1,500 or 2,000 feet in Del Norte County. And so in relative terms, even if the amount of snow and the actual mass of snow loading is lower, that could still pose structural issues because the design standards are not as high as they would be in high alpine areas. And so, yes, that is something that's a concern. The good news is that if you only have a foot or so of snow on your structure, it's a little bit easier to potentially remove some of it by shoveling or raking. Just be careful if you do that. The problem is now up in the Sierra, if people haven't kept up with it, they now have like 5 or 10 feet of snow on top of structures. That's really difficult to remove. I mean, even with professional equipment. But if you've got 6 inches or even 18 inches of snow on a rooftop, it is something you might be able to go out and do something proactively about. So not fun, not easy. Be careful if you do it, but Tuesday through Thursday is the best window to do some snow removal to alleviate some of those issues if you can. Not going to be realistic for everybody, but do be aware that is a possibility even at lower elevations from what I've been hearing. Let's see here. Yeah, there's a comment from Jeffrey about the relevance of the actual location of the atmospheric river in relation to the low pressure center. As I mentioned, this is really going to dictate whether or not a warm atmospheric river truly syncs up with a strong low pressure system with cold air behind it or not. Dictates whether it's really more of a weak to moderate plume of moisture where it rains a lot in the mountains but there's no real dramatic storm from an event that would be much more dramatic. So the reason why the atmospheric rivers from December through January were so visually and practically dramatic, with literally with thunder and lightning and powerful winds, that may be pretty different than the kinds of storms we would see during this warm pattern in a lot of places, because there are perhaps less dramatic dynamics, although there is a little bit of uncertainty. So whether or not that atmospheric river syncs up in the right location relative to the low pressure system, and how strong that low pressure system is, remains to be seen. And that's why there's still a wide range of outcomes. There's high confidence in an atmospheric river, but a weak atmospheric river doesn't necessarily produce very dramatic results. It can just result in relatively mild, warm, light to moderate rains. That wouldn't be so bad. It's still going to cause some problems, but it won't cause widespread problems. If, however, again, as I mentioned, the low pressure system can sync up a little bit more closely with that atmospheric river and draw in a little bit colder air behind the atmospheric river, those storms would be more dynamic and would produce bigger problems. Right now, we're sort of looking at more of a middle-of-the-road solution, but it could go either way. It could be pretty mild, honestly, and not produce very many severe impacts, or it could scale up and we could get bigger impacts. And that really will depend on how much the atmospheric river syncs up with the low pressure system and the cold air behind it. So it sort of remains to be seen. Right now, it does not look like it will be sort of a worst case scenario of a perfect alignment, perfect phasing between the mid-latitude systems and the subtropical moisture, but it looks like there will be some modest amount of phasing between them. But of course, this is always something that tends to be something that's not very well captured until the last minute. So this is why there's a wide range of potential outcomes. And if there are additional follow-on warm atmospheric rivers lurking out there in the next 2 weeks, each of them will then have the same potential. They could be very weak and produce mainly light to moderate rain, nothing dramatic, or they could sync up with mid-latitude storms with cold air to the north and produce much more dramatic storms. And we just don't know which outcome is most likely at this point. Right now, the weak to moderate events are the most likely ones, but we definitely can't rule out a stronger atmospheric river if that phasing occurs in a way I think that Marty Ralph described during that hearing that you mentioned there. So I am sort of running out of time. We were actually past the hour. I'm just going to do a quick review of these questions that the folks have got. Again, I'll have probably at least one more office hour later this week. Closer to the event itself, I'll have a better sense of it. Let me just quickly go through the rest of these questions here. We had quite a few today. Again, there's a lot of folks still on, so thanks for joining. Let's see here. Nathan asks, why do the major models publish the quote operational model sample as opposed to the mean or the median point estimate? Is the operational estimate just a random member of the ensemble? Well, I'll answer the second part first. It is kind of a special member of the ensemble. Sometimes it is at slightly higher resolution, so you might expect it to be nominally better representation of the physics of the atmosphere than the rest of the members. But for all, given the range of outcomes that often come from across the different members of an ensemble, for all intents and purposes, I just treat it as give it essentially equal weight to all other members of the ensemble, except for maybe just a day or two out, in which case the higher resolution maybe gives it a bit of an edge. It is, other folks may disagree, but I essentially treat it as a random member of the broader ensemble. And the question as to why it's most often publicized, that is a good question, and I think it is a major challenge in science communication. Many of the weather apps, your smartphone weather app, often doesn't have a human behind it, and it just uses this random operational number. So if folks say, why are the weather apps so bad? Why is weather forecasting so bad? Those are not the same questions. Why is the weather app so bad is a very different question from what is the accuracy of a real weather forecast, because often your weather app is not making a real weather forecast. It is just translating this random operational member from one model into a deterministic weather prediction, which from a broader scientific perspective is a big no-no. It's actually meteorological malpractice to give a 10-day forecast using only the single operational model member. The National Weather Service forecasts do not do this for precisely that reason, because it results in wild swings in the forecast from one model cycle in a 6-hour period to the next. So you might get 4 random swings in the forecast in a given day, since you run these ensembles 4 times a day generally. It's a problem. I think that it's the main reason I don't bother with weather apps, because it's essentially not scientifically justifiable to use it that way. That's why I tend to err on the side of using the full range of ensembles. Sometimes the ensemble median is still a bit misleading, but it's often less misleading than using a single operational run, because you can sometimes get clusters of solutions. So the ensemble, there might be 3 primary solutions. They're not kind of randomly distributed around the mean value. There might be some clusters of really low rainfall, a cluster of really high rainfall, and nothing in the middle. That's kind of what happened with this pattern, by the way, is that there were a bunch of model members with very little rainfall, a few members with very high rainfall, and not a lot of members in between. And as it turned out, the initial conditions that produced the higher rainfall outcomes, even though they were fewer in number to begin with, turned out to be closer to reality, I think, than the ones that were drier. So that's sort of what happened this time, and a good representation of where even the ensemble median is still going to be somewhat misleading, but it's certainly going to be less misleading than only choosing the single operational member, which in this case has ranged from like catastrophic flood to completely dry, which are the 2 least likely outcomes. And so folks have freaked out and then non-freaked out and gone back and forth, whereas looking at the full distribution of members in the ensembles, and in this case particularly looking at the clusters, are there clusters of very wet and very dry solutions, it has been the way to go. It's a science communication challenge. It's a weather prediction challenge, but I would strongly encourage folks, particularly folks who work in the media and on TV, to really think about not using operational models and posting maps of the 2-week precipitation accumulations from operational models, and really focusing on at least the ensemble medians, and even if you want to get really fancy, looking at the distribution of the individual members. I realize that's difficult, but in most cases, most of the same locations, the data vendors where you get the individual operational ones, you can also get the ensemble averages or the ensemble medians, which that's a good place to start. All right here. I think here I am gonna probably cut it off. We're running past the hour, but there's a lot of interest again. Please stay tuned. Later this week, I'll have another office hours session. I am gonna do a blog post either tomorrow or the next day, so stay tuned for that. And I don't know, for those of you who rely on Twitter for the alerts. Honestly, I don't know what's going on over there. I have my own internal suspicions about why the internal API just stopped working and all external links are broken. But who knows? We'll see if that gets fixed the next few days. But otherwise, you're here, so obviously you found your way here somehow. Obviously, if you subscribe to YouTube notifications, you'll be notified. I do schedule these in advance. I generally don't do live streams at the last second. There's usually at least a few hours of warning, often a day or 2 of warning, so you'll get that notification with enough time to join, hopefully. As always, these are recorded, and I'll always make announcements through the Weather West comments section as well, so we'll see how this goes. But thanks again for joining, and talk to you later this week. If you are in one of these locations that I mentioned, definitely take advantage of the Tuesday through Thursday window, where it may not be completely dry, but it's going to be much more benign weather than we've had recently, and potentially more benign weather than we may have for a while thereafter. So that's really the window to get out there and do what you need to do to prepare for the coming storms and clean up from the ones we've just experienced. So